All right. All right. Welcome, everybody, to MongoDB Office Hours. I'm so excited to get this started. We've been talking about this for quite some time. Eh, Rick?
Absolutely. It's been quite a while. So I'm glad to finally get a chance to do it.
Absolutely. So welcome to folks joining the stream. Today, we're going to be focusing on data models, specifically for our car reservation system. But Rick, before we begin, maybe tell the folks a little bit about yourself.
Oh, sure. I mean, as folks might know from my days back at AWS, I was the worldwide technical leader for NoSQL services and the first enterprise SA for DynamoDB. Folks who are joining might be familiar with the background. I have moved offices, so to speak, but I've taken my virtual office with me. And again, we've been talking about this for a long time because one of the things that is really confounding to new developers with NoSQL world is data modeling, and it was a very successful series that I ran at AWS was Office Hours for DynamoDB, and a lot of those same modeling principles apply as well to document databases like MongoDB. Obviously, with an extended API, a lot more functionality, a lot more neat tricks we can do, and that's what we're here to talk about today. Is how do we do these things and model these types of workloads and services? We'll talk about car reservation today, but if you think about it, this could be any kind of resource reservation service, right? But in the context of car reservations, it gives us a model that everybody can have context with and understand. So should be a good conversation.
Yeah, love that. And this is designed to be interactive. So if you've got your questions, get them ready. You can put those in the comments. Looking forward to fielding some of those questions. We're going to try and stay on track in terms of addressing the problem at hand. We're building a car reservation system, but a lot of the principles that we're going to use and the process and approach will apply to whatever application you're building.
Absolutely.
So with that, Rick, let's get right to the good stuff. Let's talk a little bit about the use case that we've chosen for today, car reservation system. First of all, where did this come from?
So there's a great repository of libraries out there on the internet that I've been using for many years, and that was put together by a man, Barry. What was it? What's his name? I can't remember the name now. It's let's see. Anyways, it's basically Database Answers is a great repository of relational schema for a variety of workloads. We can share the link there. Maybe Mike, if you have a chance, pop it in there for the people on the stream to take a look at a variety of different logical relational models for a variety of workloads, and we just kind of cherry pick individual use cases from those as we kind of go through it. Let me see, where are we in my?
So yeah, I just while you're looking, I just dropped the link in the banner there. It's MDB, stands for MongoDB, .link/car-reservation. That's going to bring you to Barry's site. A massively helpful resource, right?
Absolutely, and this is just one of those models that we're going to be breaking down. But I don't know why my screen is not. Let me go ahead and share again, and I'm going to share this, and so we can take a look at. A little bit, and it's not coming up on the stream. Is there?
There you go.
There we go.
There you go.
Absolutely. So again, we're talking about car reservation model. This is what that model looks like. It's a pretty straightforward model in this case. We've got a couple of tables that describe customers, vehicles, bookings, right? Some status tables and whatnot, and some details of the various vehicles. And what's kind of starts to become apparent when you start to look at this thing is that there's models that are entities in this model that have kind of relationships that we're really interested in traversing, right? Customers, the reservations they have, the bookings they make, what vehicles might be available and whatnot. And then there's other data that's really the kind of metadata that makes up the entities that we're working with. In this case, mostly vehicles, but you can imagine it could be any number of resources. So what I found to be interesting about this model is there's kind of, and as we kind of peel the onion here, you'll see there's really multiple ways that we're going to model the entities here, both embedded, using hierarchical embedded models, using single collection models where we can relate this data together to try and pull up, bookings and information and whatnot.
Before we leave that, I want to call something out. So this is a model. If you could go back one slide.
Sure.
This is a model that was developed for a relational database, and we're going to demonstrate how to take this conceptual model and model it for a NoSQL database. So if you're just joining the stream, What you see on the screen is a conceptual model for a car reservation system. It's got all of the data elements that we've thought about for an application that's going to help users book cars. So if you're familiar with car rental systems in the US or around the world, these are kind of the data elements that'll be present. And then we're going to take this from conceptual model and deliver a data model for MongoDB.
Yeah, document model, right? I mean, and this is actually a really good point that I should have talked about that right off the bat, is that, data is relational, right? All the data we work with as a developer, it's all relational. It's all about the relationships, and modeling those relationships efficiently is what really drives whether or not a database is going to work for you. And so when we get into it, at the core of every database is the logical data model. And this is what this is. It's the entity relationship diagram, right? It's we have customers, we have vehicles, we have bookings, and then vehicles have metadata that's related to the model of vehicle, the manufacturer of the car, whatnot, the category of the vehicle. Bookings have some status that's associated with them. But the primary entities that we're working with in this particular model, if you think about it, it's customers, bookings, and vehicles, right?
Yeah. And where you typically, in a relational world, you start by dividing the data into separate tables. That's just how you do things.
Yeah.
With a document model, the first thing we're gonna do is think about the application, and then we're gonna list out all of the data elements that the application will manage, and then we're gonna set about the process of building the document model.
Well, and we're going to use the way that we've used the data, the way we access the data, right, to actually build the model so that we can do it most efficiently. And honestly, I was funny because I talk about this all the time. I just had another conversation earlier today with the customer. Even in the relational database, if you think about the access patterns first, we're going to drive efficiencies that will benefit us down the road, right? Many times when we scale those relational database applications that we think were so well written, we find that maybe they weren't so well written, and then DBAs come clean up the mess. So I know a lot of DBAs that actually would really appreciate developers follow this access pattern first methodology, no matter what database you're working with. It's always good for the business. Yeah. Anyways, as you talked about, we had these data elements that we're working with in this case. Our primary things that we're going to be interested in are bookings, customers, and vehicles. Vehicles have different types. They have cars and vans. And those are kind of like just derivatives, so to speak, of a vehicle. They're different types of vehicles, but they do have different metadata, right? And in a relational database, this would typically mean additional tables that need to be joined in to produce a list of vehicles that are available, right? And that can start to cause some overhead as we start to join tables, right? You put tables together. Every time you see join in a relational query, you're talking about CPU cycles. It's funny. I was just talking to a top 5 consultancy earlier today about this, a sustainability initiative that they have, and how the joins in a relational database can actually introduce time complexity, which introduces additional overhead on infrastructure. And that's what we're really trying to focus on here, is driving efficient data models and using the data model to reduce the overhead on the CPU, as we'll get into in a second. So how are things related, right? That's really what it comes down to. We want to understand the logical data model, how these things are related to each other. And what we can see in the relational diagram is a booking is for one vehicle, one customer. Okay. Customer can be associated with one or many vehicles through the bookings that they make, right? So essentially there's a many-to-many relationship between customers and vehicles, and it's the bookings table or entity that defines the mapping between those vehicles and those customers, right? So that's an important relationship to understand, right? And a lot of people, it's kind of simple to comprehend how to model hierarchical relationships, but many-to-many relationships, right? Parent-child is easier, but many-to-many we're going to get into here. And how do we do that? Well, in their model, they're saying customer can't hire a vehicle for longer than a week. Honestly, in reservation systems that I've worked with, I can hire my vehicle for as long as I want. So we're going to go ahead and ignore that restriction. A customer can have one or many invoices. Vehicle can be a car, van, invoices for one and only one customer, right? So as we get into the access patterns, right, that we're going to model for, and this is really what we want to understand, the primary pattern that we'll probably get into modeling today is really about customers creating bookings, right? So as we create a booking, what do we need to know? We need to know what vehicles are available when we make that booking, right? So if you go online and you look at the car reservation model, you'll see a large number of patterns, and we might get into one or more of those today, but the one that we'll primarily going to model will be the booking, right?
So can I interject one question? So go back one slide,
Sure,
and we've got some things in there that represent access patterns, but also constraints. So, for
sure.
example, a customer cannot hire a car for longer than a week. Why would it be important to include that in the access patterns?
I mean, it's one of the things that defines the query, right? So that would be a
Okay.
query condition, right? So I would,
Hmm.
as I try to put to get things together in a wiki or that document the service, that document the data model, you're going to define your entity documents. You're going to define how these things are related, how they're structured, whether they're created as embedded documents within each other or as a collection of documents that are use common attributes and are indexed together.
Hmm.
Uh, we're going to then what we're going to do is define the query that's associated with every single access pattern, right? So
Hmm.
essentially, these are your user stories. A lot of times I hear customers say, well, but maybe I don't know my access patterns before, we have to write code. I'm like, and I say, well, then it's time to write user stories, right? And not code. Because
Yeah.
if you don't know what your access patterns are, how can you write the code? I mean, the
Yeah.
code contains the query, does it not? Right. So, I mean, this is really what it comes down to is that we know how we're going to work with our data. Yes, we will refine
Ooh.
those queries over time. We will add new access patterns and whatnot. But like any data model, it needs to evolve, and NoSQL data models are no different. What I'm interested in is modeling for what I know, and
Yeah.
that's what OLTP applications are all about. They're about
Yeah.
queries that are well understood, not queries that are some random thing that the guy's going to ask, analyst is going to ask tomorrow, right? It's
Yeah.
essentially we're modeling for queries that run hundreds of times a second,
Yeah.
millions of times a day, right? That's
Yeah.
what we want to know,
So,
right?
so before you go on, we have a question from Satyender Hanglu. He's saying, "Is it to limit the joins?"
You got it. That's exactly the
Yeah.
idea here is right now for the high velocity patterns, right? We don't want to be running joins 1,000 times a second. I don't care if you have to join data to be able to run a complex report every now and then, right? Every, once an hour, at the end of the day, at the end of the week, no problem. And then we give you the ability to run those complex aggregations, right? But one of the patterns that we often recommend is called the computed pattern, where you run the heavy query, at a very, heck, even if I have a high velocity status indicator that needs to be executed, maybe I run that heavy query every 10 seconds, every 30 seconds, and I have those millions of requests per second looking at the status. Guess what? They're looking at the output. And it's, well, I don't need to run that query hundreds of times a second. I don't want to do that. That's where it gets expensive.
Yeah.
So essentially, if I need current up to date information, then what I want to run is queries that don't contain the join. Right. That's really
Yeah.
the idea. And that's what we're going to get into here when we actually start modeling these documents.
Yeah. Yep. Great.
All right, so here we go. This is that physical model of the data, kind of breaks down the individual documents or the individual entities and what the attributes look like as far as typing and whatnot. We don't necessarily need to get too much into that. But what we want to start doing now is actually modeling this data. So let's see here if I can actually share the data modeler. All right, so folks who are familiar with my days at AWS will be familiar with this tool. I used to use a tool. It's basically a DynamoDB. It was a partition modeler, and MongoDB, essentially what we're working with is it's an index modeler. And I'm just going to create some mocked up collections here for some documents, and we'll take a look at what these things look like. So this is a car reservation system, and we're going to have a collection of documents. Now, collections in MongoDB can contain many types of documents, right? And so in this case, we'll have one, it's a vehicle, and this is going to be a resource that has some availability. And in this case, the document's going to describe essentially the data that I'm looking for when I want to look up this vehicle, okay? And that's going to be some sub-document. In this case, I'm not really all that interested in that data because it's just all the metadata that we see on the table, right? It's all those extended attributes, what type of vehicle is it, who's the manufacturer, maybe some information about the various metadata. And I might use that metadata to filter the vehicles that I'm looking for, right? But I'm not necessarily, going to be too worried about those from a data modeling perspective, because what I'm really interested in is the things that this vehicle might be related to. And in this case, the only thing that the vehicle is really related to is itself. So, there's nothing else for it to be related to. And the reason why why am I doing this? We'll see this in a second, because this is essentially the grouping attribute. This is what I'm going to index to kind of produce relationships to the vehicle itself, right? So let's go ahead and save this. And we've got a schema change now that's been detected. So we created a new type in this particular entity, which now has a type of vehicle. It has a data attribute, which is a subdocument. That's really, again, this is a modeling convention I have. You can choose to put these extended attributes that define the object anywhere you want.
Yep. So Rick, I'm going to jump in again. I'm going to be that annoying co-host where
absolutely.
We're looking at it looks like JSON, but I want to ask you first. Can you Command plus? Let's get that a little bigger. So
a little bigger, sure.
A little bigger if we could do that. There we go. Hope that's better. Jesse's behind the scenes. Good. Yeah, he's got the thumbs up. Thank you, Jesse. So we're looking at what looks like this is a JSON document. No.
Yes, absolutely. And that's one of the things about document databases like MongoDB and really NoSQL databases in general. They kind of treat everything as a JSON object. Wide column databases would deconstruct these into rows and columns, but in the end user's perspective, it's all JSON, right? And that's very familiar for developers, right?
So we're going to ask a trivia question going forward. You can get your hands on a MongoDB t-shirt just like this one without the seeing through it on the green screen. But we're going to ask a trivia question coming up. So I want the listeners to stay tuned and pay attention. We're going to answer the question, and we'll ask folks a little later on. So we're looking at JSON, but it's not stored in JSON. What's it stored in when it hits disk?
Well, it's stored essentially as a document. It's a BSON document, right? In MongoDB, right? Which is a binary representation of essentially what developers would perceive as JSON.
Correct.
Right?
Okay.
Nice thing about BSON is it has native type support for an extended, array of data types, right? Native dates, types and whatnot that go beyond the JSON accepted types, right? So you can have actual longs and ints and all that extra extended typing, right? Is what you get from BSON, and a compact binary format for transmission over the wire, right?
Right on.
Yeah. Cool. All right. So that's our first document is the vehicle, right? Vehicle is related to itself. We're going to go ahead now. We're going to create a user or a customer. And so we're going to have C1. C1 is a customer. Right, customer is going to have a similar data structure. He's going to have some metadata that describes himself. It's going to be different metadata, right? But I always like to include this subdocument that essentially has the extended metadata that describes the entity itself, right? So, and then of course the customer will be related to probably multiple things here because eventually he's going to start renting cars. But for right now, we're just going to give him a relation to himself.
I love this. So I haven't seen you do this before, but I'm gonna guess. I'm gonna make a guess. That related to field, is that going to be used for diagramming relationships?
Well, yeah, kind of indicates that's what it's going to be used for. Right, exactly. And what we'll see here is when we index this related to field, some interesting things are going to happen, right? Essentially, what's happening right now is I'm creating a bunch of what you would perceive to be rows on tables across multiple tables in a relational database, but I'm kind of putting them all into one place. And if you think about what the relational database is really responsible for, it's responsible for joining tables, merge sorting, indexed queries across tables, right? And if you were to put those rows into one place and you were index a shared attribute, I don't necessarily need to join anything anymore, right? The indexes becomes pre-joined, and we'll actually get a visual indication of what that looks like in a second when we add now. So what happens is I've got a vehicle, I've got a customer, and what's the customer going to do? The customer is going to create a booking, right? So we're going to call this a booking, and bookings are going to have some attributes. They're going to have maybe a few more attributes that are more interesting to us, but they're going to have some data, of course, that describes the booking, and this could be the type of booking or whatnot. Again, just the metadata around the booking. They're going to be related to a couple of things, right? They're going to be related to the customer that made the booking, and they're going to be related to the booking itself, and they're going to be related to the car that was reserved, right? So let's see, our vehicle 1 gets reserved by customer 1, C1, and then they're also going to have a start date, right? Which is going to be some sort of date time attribute. And this would be, we'll use an ISO string here. So this will be 2023. What's the date today? 06 dash, let's say it was rented today. And at noon. And it's going to have an end date. And let's say it ends tomorrow at noon. So it's reserved for 1 day by customer 1. That should be proper JSON. Yep, there we go. All right. So now, if I create an index on related to, okay, we can see one thing right away that'll happen is that I will see anything, all the bookings for car 1, all the bookings for vehicle 1, or I could obviously select the booking itself by what's related to it. If I decorate the customer with the booking he makes, right, let's save that. And I'm going to decorate the vehicle with the booking that he's related to as well, right? Vehicles. Now, this is where you start to get into how many bookings might a vehicle have over time, right? And we don't necessarily want these arrays to grow without bound because that can be a bad practice, right? As you add items into these arrays, it becomes more and more expensive to update, not only add the items into the array, but it becomes more expensive to update the documents as the documents grow in size. So this is important to understand, well, how many bookings might a vehicle have? And how might I want to, deal with those bookings? I might want those bookings to expire over time. I could set a TTL on the booking documents. When they expire, I could clean those booking references up across these documents using a trigger. Somehow I have to have some life cycle associated to making sure that the arrays that the vehicle has in the related to category don't get too big, right? Or maybe I can understand that over the life cycle of the vehicle, it'll never have more bookings than I need to worry about. But these types of considerations when you're maintaining arrays in documents are important to kind of understand what exactly you're doing. Now, the other thing that is in consideration in the model that I'm showing folks right now is this is a neat trick, but it's not a trick for every use case, right? We need to consider what's happening with the data set here. Creating references across documents like this is a great way to model relational data in relatively smaller sets. But if I have large numbers of relationships, this can become a cumbersome process. And the other thing to understand is on very large data sets, this can also have an impact on memory, on cache, because what I'm essentially doing is I'm creating and collecting a large numbers of small documents. So it's much more suited to write-heavy workloads, which actually works very well for most OLTP workloads, or smaller data sets that fit in memory. So I'm not actually churning the data in and off of disk, right? We can, if you're interested in some of the ways that, this can impact the file system, we can actually have some of those discussions as well. But for now, let's show, the actual, what the modeling looks like, because that's the most interesting aspect here. So in this case, the vehicle now has been associated to, a customer, it's been associated to a booking, it's now associated to himself, right? And the reason I'm kind of doing this is because we might have dimensions that say, give me all the customers that rented a vehicle. Give me all the, bookings that are associated to a vehicle, right? Get me all the, so on and so forth on these various dimensions. We'll add some time-bound criteria here because I know that's the next question that's coming. But for now, let's see what this looks like on our index, right? So essentially, I can say, get me everything related to booking 1. What am I getting? I'm getting the vehicle, I'm getting the customer, and I'm getting the booking, right? And essentially, I don't have to denormalize this data across multiple documents. I can update the metadata of the vehicle, the metadata of the customer, or the metadata of the booking. It's not going to impact, right? It's not, I don't have to update that data in more than one place. If I redefine this index a little bit and I say, okay, let's add some fields onto these documents, which would be customer has a start on his own relationship, which would be essentially the beginning of time, right? And so let's say that would be, Y2K. And let's say he has an end, which is the end of the universe. So let's put him out to 9999. Right. And now if I say, so what I'm essentially doing is I'm adding a start and an end to every document so that we can add those attributes to the index, right? And it'll be interesting how you have to do this. I'll show you in a second, but I'll explain also why we have to do it in a kind of
while you're doing that, I want to explain to folks that are just joining the stream. We're building a document model for a car reservation system, and Rick is demonstrating a tool that he wrote. This is the document modeler for MongoDB. It's just is that open source, Rick? Is that available?
Yeah, absolutely. And I can post a link into the chat.
Yep.
Let's go ahead and do this.
So Zachary Taylor was asking, he's a little lost. He's mentioning that, there we go. Sorry, I'm fighting Jesse for banner space. But he's saying this is the first time seeing the MongoDB index modeler, so he's a little lost. Just wanted to explain that to folks.
Oh, yeah. This is just, think of it like an Excel spreadsheet. It's basically creates pivot tables when I define an index. You could do all this in an Excel spreadsheet. I just find it easier to have a little tool. And the reason why I like this is because it allows me to visualize the indexes. It resorts the documents into those index partitions. It helps you kind of visualize the model, right? How would I query this? Now, I could use Compass and I could write the queries and you'll see the result sets, but it doesn't really give you that idea of how things are grouped, right? I mean, this is kind of a B tree view, right? This is what the index looks like. And why it's important, I'll show you right now, is we're going to redefine this index 1, and it's going to be a compound index on start, end, and related to. Okay. And so now it's going to be, we can see what's going to end up happening here is this index starts to look a little more interesting. If I look at, what happened? Start, end, related to something. That's the other thing about this tool is that it's not always working so well.
It wouldn't be a demo. It wouldn't be a demo if something didn't go.
If something didn't break, right? Right. Did I mistype something? Start and it's not gathering those documents for some reason. Let me try index. So it's giving me that. Imagine we had an end date in between this start and related to. And I have a bug in my index modeler I need to go fix. And this is the problem with these self-written tools is I'm the only maintainer. So when there's a bug in it, I'm the one who gets to fix it. So, but what we really want to do is I want to put a range condition here. And I want to say, give me everything that is between start date and end date. And is related to X, right? So I want to get all the reservations that have been made between a given time. I would say, find where the start date is less than the end date of my current reservation that I'm looking for, my reservation period, and the end date is greater than my start date. Okay, so if I did that, then essentially I would get a list of reservations back. For vehicles, right? And that's and I really apologize, folks, but this is unfortunately not having this index is going to hurt us a little bit. But what I'm querying for is the bookings. Okay, so when I go to make a reservation, this is probably a better way to explain this. When I go to make the reservation, I'm going to have a inventory of assets. In this case, I'm going to have a yard full of vehicles. There might be a couple hundred vehicles in that yard, right? The application is going to be aware of all those vehicles that are in that yard. Because I can essentially say, get me all the cars or all the vehicles by yard ID. Yard ID might be one of my data aspects, right, that are in my data. If I'm querying by yard ID for all the vehicles, I'm going to have an inventory of available vehicles. And then what I need to see is which vehicles are reserved. Because if I know what vehicles are reserved, then I know what vehicles are available, right? Yeah. So the query that I'm looking for is all bookings that are active during my requested reservation period, right? So if I query, I say, give me all bookings that have a start date less than the end date that I need, and an end date that's greater than the start date that I need, right? Then I'm going to get the booking listings that are active during my requested window. You see what I'm saying?
Mm-hmm.
Okay. And once I have a list of bookings, then I know what vehicles have been reserved. I can knock out the vehicles that are available, right? And
Mm-hmm.
that's kind of the way that the model would work here. I would create a booking. It's in the system. The booking has a start date. The booking has an end date. And it has the associated vehicles. So when I'm looking to make a booking, I'm really looking for what's reserved in order to determine what's available.
Got it.
I hope that makes sense. Does that make sense?
I think so. If not,
Okay.
let us know.
Are folks following that?
I think so. I don't see any questions about it. I think we're doing good. Yeah. Okay. So let's just review the process so far. We've embarked on creating a car reservation system. We looked at the possible data elements, the universe of data that we want to manage with our car reservation system. We've then started to look at the access patterns, and we're distilling those into a set of fields in a document.
Right. Yeah. So again, if you imagine that in a query where, and it's probably better to index on type.
Yep. Okay.
Now, if I index on type, I have bookings, I have customers, I have vehicles. If I query for the type equals bookings, I have a start date less than my end date and an end date greater than my start date, then I'm going to get a list of active bookings. Okay. Active bookings gives me then, I can use the active bookings during my requested period to knock out the vehicles that I need to, select from. Do you see what I mean? So I'd say my first query would be, and let's go ahead and add to vehicles. We'll add the yard ID or lot ID. And this would be lot ID, let's say lot ID A, save, change. Now, if I add an index on lot ID, when I query for lot ID, I'm going to see all the vehicles in lot ID A. If I add another vehicle, I can essentially copy the data here, add the vehicle. I don't necessarily need this vehicle, is not on that booking, so we're not going to leave him there. This is vehicle 2. Save. Now, if I index 2, I can say, give me all the vehicles for lot ID A. I can get vehicle 1, vehicle 2. I can query on index 1 for bookings that have a start date less than the end date and an end date greater than the start date. That means they overlap my window. If you think about those two criteria, right? I'm essentially looking for reservations that either that extend into my window or start within my window. If a reservation extends within my window or starts within my window, then it overlaps me. That vehicle is not available during my reservation period. That's probably the best way to explain that.
Love that.
Right? That's why those criteria are important, right? I need to have, I'm going to say I want to reserve this car, between, the 28th and the 1st of July, right? So if you think about that, I have a booking that's active, that's less than my start and greater than my end, or less than my end and greater than my start. That means that vehicle 1 is no longer going to be available for me.
So Rick, a question from Warith he's asking, are we going to write any queries to fetch these?
Right. So I'm actually showing the data model here, the document model. I wasn't actually intending to write the queries. We're actually trying to set the data model structures up here so people can understand how those documents need to be built. And now what I'm actually realizing is we look in this model that I probably should have had some queries ready to write here and we can do that. I don't mind doing that, but it's a little bit unplanned. If we want to take a few minutes, I can just go ahead and fire up.
I'll bring folks up to speed on where we're at. So welcome everybody. If you're just joining the stream, this is MongoDB Office Hours with Rick Houlihan and myself, Michael Lynn. We both work at MongoDB, and we both spend a whole lot of time working with customers, solving problems with applications and data. And today we're trying to wrap our minds around what it would be like to create a car reservation system. So a system that rents or leases out cars. And what Rick has done so far is we kind of talked through the process that every application developers should go through if they're going to leverage a document database like MongoDB. We started looking at the data elements, the universe of data elements that the application will manage. So we talked about there being cars, vehicles, customers, and bookings, and we've mapped those out so far in a basic JSON model. We're going to ask a question coming up, how MongoDB stores data, so stay tuned. We're going to pick somebody at random that answers the question correctly, and I'm going to connect with you on social media and get your contact details so I can send you a code to get a MongoDB t-shirt. So if you want to win some swag, stay tuned and listen up. We're going to be asking that question very soon. And then so back into what we're doing now, Rick has created a document model and is going through the process of defining the indexes. So indexes are important in databases in general. A lot of folks think, well, MongoDB is a document model. It's not a relational model, not a relational database. So you don't need indexes, right? Well, that's not correct. So indexes are very important to efficiently access the data within your database. And that's part of the process of developing an efficient document model. So ensuring that we've got the document model planned. We're planning for all of the data elements that our application will present to the user, as well as update. So create, read, update, and delete. We got another question. MongoDB fits OLTP model database. That's a good one for Rick.
I'm sorry, Mike.
Yeah. So does MongoDB fit with an OLTP?
So, I mean, actually, that is where NoSQL databases tend to shine, right? Is OLTP workloads. We want to model the data to support efficient access patterns, to maximize the efficiency of the high frequency access patterns. And in order to do that, we need to understand what those patterns are, right? So OLTP workloads have well understood and well documented patterns. They always run the same queries every time the process runs. So they're great candidates for NoSQL databases. Absolutely.
Yeah. Great question. What if the data relation is huge? I love this question because it's something that I get quite a bit. I don't know if you're still trying to work on that, Rick, but go ahead.
Yeah, I'm actually having trouble bringing up my MongoDB instance. I'm not sure I'm going to be able to get that running during this session, unfortunately.
No worries. We can always address it in a future episode. We plan to do these on a monthly basis. What if the data relation is huge? What if the aspects of the data present a highly relational model? So I would answer this, that MongoDB can serve that purpose as well. We have two types of ways that we express relationships in data within MongoDB. And the preferred method is to embed data. So embed it in a document that may result in duplication of data, but there's another way that you can do that. You can express a relationship between two data elements by linking between two collections of documents. And it's up to you as the application developer to make the decision as to what's going to be most efficient, most performant, based on the access patterns of the application and the user. So that's the great thing about MongoDB. You get to make those decisions based on not rules that were created back in 1950 or 60. It's based on the usage of the application and the access patterns that are manifested in the application. Right. Would you add anything to that, Rick?
Yeah, absolutely. So, I mean, that's one of the things that, as you described, there's multiple ways to express relationships in MongoDB, and I was going to use essentially that was partly what I was trying to do with the car bookings model, but Nate didn't do such a great idea. Let's go ahead and share the modeler again, so that I can kind of, what you described was there's two ways. So we can embed or we can reference, right? And when you reference, you have a choice to, and I shared the modeler, but it's not coming up on the screen. Is there something I need to do to share it to get it?
Oh, here we go. Yeah, I got you. I got you. There you go.
So again, what we'd like to do is essentially, if you create two documents that are a parent and a child, between that have a parent-child relationship, more or less. In NoSQL databases, essentially what we're trying to do is not necessarily separate these into multiple collections, because when you separate into multiple collections, then you have to either denormalize and duplicate the data, or I have to use a dollar lookup or join the data. And those are okay options depending on the nature of the access pattern. But a lot of times what we really just want to do is we just want to look up what things are related to each other. So and that's really about using these indexed, relationships. If we create these related to document references, then when we index these documents on the together, then we can essentially pull back a collection of related documents. So in this case, let's say I have a parent document, again, related to himself, and then I have children of this parent that are related to, and again, this document might have a variety, a whole ton of data in there, and there's other things that are related to these things, children of that document. And these things then only need to reference the parent themselves, and I can have multiple children referencing the same parent. And when I make that index on that related to, I'm going to be able to pull back all the things that are related to a given document very easily if I create the index on that related to array. And so I don't need to put things in different documents. I don't need to put things in different collections. I don't need to, let me put this up on the screen real quick, create. And so again, if I want to select where everything related to parent one, I can pull back multiple documents without having to denormalize the data. The only thing I have to do is essentially create the references between the documents in these attributes, right? And if I store them all in the same collection, then that common shared index means there's no join.
Beautiful.
Does that make sense?
It does.
Yeah. And that's the real idea here, is that, and then I can create multiple children, essentially. And as long as those children, they can all be related to the same parent, they can all have different data, right? And when I go to the index, I now have two children of that parent. See what I'm saying? Yep. So essentially now this is a nice way to be able to track relationships across documents without duplicating the data. One of the things we found at Amazon was that 70% of the access patterns for OLTP applications were for a single row of data on a single table, right? 20% more were for a range of rows on a single table. And it was really a big clue for us, because what it taught us was applications use data in bits and pieces, right? Applications don't necessarily use data in big, large chunks. Now, some do, right? Now, depending on the nature of the access pattern, right? So if I have a read-heavy access pattern, like a product catalog, right? A product catalog needs all the product data all the time. It searches for products by category, for products, in various dimensions, right? Sorted by, on properties. But I'm not necessarily accessing the data that's related to the product in bits and pieces. I'm accessing the whole product. And that's more of a read-heavy pattern. So large embedded documents make more sense for a read-heavy pattern.
So important to make that distinction and base it in, like, it comes down to physics, right?
That's exactly right. I mean, this is really what we do in the end, is we want to know how much data we're moving, for what reason are we moving the data, how is it impacting the system, right? What are the considerations we need to make, and how we structure the documents. The mantra in NoSQL data modeling is essentially data that's accessed together should be stored together. Either it should be stored in a single document, in a rich embedded document, or it should be stored in a common and shared collection, right? Can I use some other key or attribute apart from underbar ID? Absolutely. There's, in this particular case, we're referencing documents by ID, but you can also reference documents by type, or, by any attribute. We can index on any attribute.
I'm going to rapid fire some questions. I'm not familiar with the concept of soft parsing and hard parsing like SQL. Are you, Rick?
I'm not familiar with that terminology, soft parsing versus hard parsing. Is this is that clustered indexing? I'm not sure what that's related to.
Yeah, sorry, I don't have an answer to that one. How about this one? This might be a good question. What are the ways or methods that should be followed for disk becoming the bottleneck?
Ways or methods should be followed for disk becoming bottleneck on workloads. Well, I mean, again, the key there is how much data are we moving, right? If I have small updates going into large documents and I'm moving a bunch of data I don't need to move to make those updates, then I can increase disk throughput by reducing the size of the documents that I'm working with, essentially creating collections of smaller documents, right, that are being updated independently of each other, is typically a better way to, work with the data rather than creating large documents. If you think about it, when I create a large document, if it's 400, 500 kilobytes, right, and then I update an integer value within that job, maybe I'm updating a counter, right, within the document, then I have to move 400 kilobytes of data to update an integer. That's not exactly the most efficient way to update the data, right? You probably want to move less data than that. And that's the key here, is understanding how is this data related to each other, right? And how is it accessed in the context of each other, right?
Right.
If it's always accessed together, then it's probably a good idea to put it in the same document. Right. If it's not, if it's updated in bits and pieces of a larger relational structure, it's probably better to put it in multiple documents and reference those documents together.
Hey, Rick, guess what time it is?
It's probably time to be done.
No, it's not.
Right.
It's time to do two things. Number one, thank everybody for joining the stream. Really appreciate everybody stopping by with their thoughtful questions. You can subscribe to our YouTube channel, youtube.com/MongoDB. We'd love to see an uptick in the subscriptions. You're gonna do a couple of things by doing that. You're gonna make sure that you can get notified when we have future episodes of MongoDB Office Hours, but also many additional programs are coming out on MongoDB TV. You can find more information at mongodb.tv. Super excited about the shows coming out. There's a bunch that are weekly, and this one, MongoDB Office Hours, is going to be monthly. Guess what else it is? It's time for the MongoDB Office Hours question of the month. What format, and don't give it away, Rick, what format does MongoDB store documents on disk? I'd like people to put their answers in comments, and we're going to choose somebody at random. I'll reach out to you and make sure you get a code to get one of these nifty MongoDB Podcast t-shirts, which I gotta get one of these for you, Rick.
Absolutely.
So go ahead and slam those answers in the comments. It looks like a few people are answering. Oh boy, here we go. Yeah. Okay. So good stuff. Keep those answers coming. I'm going to star a couple, and you should be hearing from me shortly. Make sure you look for your connection requests and outreaches on YouTube. So that's the question of the day, of the month. What else do we got to talk about, Rick, in terms of developing a document model for the car reservation system?
I mean, honestly, I think we kind of failed at that. We did okay, I guess. We didn't really have the right. I didn't have the right visuals there, and I apologize for that, folks.
It's okay.
But I do think we did talk a bit about things that matter, right, for data modeling, and that's what the most important thing here is, that people walk away from this, and feel like they gained a little bit of knowledge, and I hope that people do feel like that. The key thing for me, if you can take away anything, is that we need to be able to model relationships efficiently in a NoSQL database to be able to use the database. There's a lot of ways to do that in a document database like MongoDB, right? We can use embedded document structures. We can use, documents linked with indexes. We can use denormalization across collections. But the key thing in all of it is understanding, what are the access patterns that we're trying to accommodate here? Which are the ones that are running at high frequency? Because those are the ones we care about. And what does a model look like to make those most efficient, right? So,
Marcus Egan dropping by in the comments. What's up, Marcus? All right, we got a lot of really great responses. I'm going to go ahead and tag some of these so that we have them. Thanks everybody for playing along. The correct answer is not Wired Tiger. What's Wired Tiger, Rick?
Wired Tiger is our storage engine, which backs the document storage engine for MongoDB. It's actually one of the reasons why we are as performant as we are. But yeah, no, it's not the actual storage format of the documents on disk. It's the tool. It's the engine that stores them.
Yep, outstanding. All right, so this is the first episode of MongoDB Office Hours. I'm so excited. We're going to be doing this on a monthly basis. It'll be on a Friday usually. And we'll take your suggestions. If you have a use case or a document model that you're wrestling with, hit us up. I'd love to hear from you. You can subscribe to the YouTube channel. You can hit me up on LinkedIn. Would love to hear about your specific challenges and document models you want to look at in the future. What's What's on your plate these days, Rick? What are you doing at MongoDB?
I run the strategic accounts developer relations team. We focus on our largest, more strategic customers. And really what we do is we try to enable those customers to understand, how to model their data for their various workloads that they're working with, right? How to do things better, and understand what those best principles and best practices are for, data modeling, right? It's that's where we find that developers actually have the worst experience in moving from relational database to NoSQL, right? Is understanding what the data modeling should look like. Developers make a pretty common mistake is to try and make things relational, right? Create lots of collections, use lots of join operations and things like this. NoSQL databases can do that, but we're not the best at that, right? That's not what we're built for. We're built for, object-oriented data structures, which map very closely to those that you use in the application layer, right? So getting developers to kind of understand that there's not a need to abstract yourself from your storage anymore, right? Through this relational database, which essentially just deconstructs your objects as you work with them, right? It deconstructs them, writes them to disk, and then it reconstructs them when you need them. And so getting developers to understand that, the structures on disk should look more like the structures in the app, and what that really means is essentially my mission, my team's mission.
Yeah, right on. Yes, MongoDB was named after the middle of the word humongous. Great question. That's awesome. All right, we're just about out of time. Any final thoughts, Rick, before we part? I can't emphasize enough that pattern first, right? Type of development approach. You should always think about your access patterns, right? That's going to drive efficiency in your solution, no matter what database you're using, whether it's a relational database or an NoSQL database. What you really want to get is the data model correct in order to be able to build a scalable application. And that's, essentially what we want to, talk about more than anything, get people to understand. Beautiful. Awesome. So thanks everybody for joining. Join us next month on Friday. Watch mongodb.tv for updates and scheduled programming. We've got some great programs coming out daily. So Monday will be The Index with Megan Grant. You can catch all of the updates from the MongoDB community. It's going to be out probably sometime around the first, the crack of dawn in Eastern time zone on Monday. That's going to be a weekly show. And then we'll have the MongoDB podcast live on Tuesdays. So you can subscribe to our YouTube channel, youtube.com/MongoDB, so you never miss a show. Thanks everybody for coming. Rick, it's been great.
Yeah. Thanks, Mike. Next time we'll do better. Sorry about that.
We'll have some queries lined up.
Absolutely. Thanks, guys.
Right. Thanks, everybody.
Talk to y'all later. Bye.
Have a great day.